2, 1.
And we're live.
Hello, everyone.
Hello.
Yeah, we're live now. So thanks for joining us. This is the second meeting in 2018. The last one was in January. So there are basically three proposals we want to discuss today. The first one is Opaque Types. The second one is the by name implicit arguments, which is a proposal that Miles has submitted recently, and we're going to decide whether we number it or not. And the third one is not a proposal, but rather an overview of what changes will be included in Scala 213. The idea is that people in the committee, or the members of the committee have, and will be trying to shape up a little bit more these ideas and try to see if we can convert them into proposals we can discuss more concretely. So as per Eugene's request, we're going to start with the third item. And I guess that Adrian is the one that will be speaking the most here.
Unless you interrupt him so often.
Yeah.
Well then, let me open it a little bit.
Yeah.
Well,
so basically, there are three items that brought, took my attention.
Okay.
And the first one was removing package objects, and
well, inheritance from package objects at least.
Yeah. And then we finding a replacement for the valid use case that they provide to kind of provide modules, right?
Mm-hmm.
Module-like functionality.
So you mean that package objects can no longer inherit a class or a tray?
Yeah.
Yeah.
So I mean that would be the least ambitious change, I think, because that, there's all kinds of issues with that. It kind of accidentally works most of the time, but not, when it doesn't, it's pretty surprising. I would like to go as far as just having top-level definitions.
That's a big change, though.
Yeah, I don't know. I mean,
it's true that we can hardly remove package objects altogether without adding top-level definitions at the same time, because it's too late to do that. Like, Ecosystem uses package objects everywhere.
Right, and so I think a more constrained mechanism that is like package objects internally could implement a lot of what people would want as top level.
So I've thought a little bit about this, and I see two ways we could do that. One is the coupling way, which is top-level definitions end up in a class, in a package object, but whose binary name is determined by the source file name, which means that, of course, if you rename the file, that's a binary incompatible change. But otherwise, it works actually quite well.
Yeah, it sounds like a pragmatic solution.
It is a quite pragmatic solution. The other possibility is for every top-level definition to define a class of its name that holds that unique member and holds a signature that make it work. So that one solves the binary incompats problem with respect to the name change, but it does create a lot more class files, of course.
Mm-hmm.
But I basically only see those two options as reasonable. And other than that, I don't think it poses any problem, like in terms of type checking or stuff like that. It shouldn't. It's only a matter of deciding how to encode it.
Can I ask a question, Adrian? What are the actual kind of concrete implementation problems that we have with package objects right now that make it desirable to make this change?
So when you want to list all the members in a package, you have to know what the super classes of the package are. And so then you have to go find those classes. And if they're in the same package, it gets weird. I don't think, to be honest, I just made a list of things that I see are often a problem. I haven't thought about it as much as, many others at the table have.
Well, I guess my thought is the current pain sufficient to justify the pain of removing the feature and replacing with something else?
Yeah, I think so. And I kind of see like the desire to have package objects be completely universal with other objects, but then we have to impose a lot of other kind of ad hoc constraints already on them anyway. So I think we might as well go a little bit further and simplify them. And I think most people are just using them to collect top-level stuff. And there's a few other use cases that like to group things together so you can easily import all of them together. I think you could easily just do that with a regular object and just import from that object.
I guess I buy that, and I mean personally, I think my own uses of package objects are just what you described to basically provide somewhere to put a bunch of top-level definitions. So that makes sense. There is one thing that I guess I'm sort of, I mean, I don't know how much I really care about this, but I remember years and years ago, and one of the things that motivated the introduction of package objects was this idea that we wanted to make packages and objects more like one another, and ultimately go in the direction of basically replacing packages altogether by just nested objects. And this is a pretty clear statement that actually we're not going to try and do that anymore. We're just going to forget about that whole idea. And package objects were a sort of halfway house on the way there. Let's just say it didn't really work. Let's throw them out and go back. Is that fair?
You know, like, yeah, that would be my gut feeling. I didn't put together like a whole case file for this, so I don't have exactly the problems. I just have this feeling of when you look in the bug tracker and you talk to people about the surprises they've had, or when you think about incremental compilation and the challenges that you've had there, or other tooling, you know, like IDEs that have to list all the members in packages and thus package objects and so on.
If I may add a data point, I absolutely agree with Adrian. The implementation is really tough and it's not correct. So if you, because everyone inherits, so the package objects usually inherit a class defined in the same package, unfortunately. So that shouldn't even be visible, but it is. And now incremental compilation or any kind of compilation relies on the order in which those files are passed to the compiler, because you need to see the superclass first, and then you can type check the package object, because then you know the superclass. But if this superclass somehow starts depending on a member defining the package object, a type alias or whatever, you cannot compile them separately anymore. So you have to pass both of them on the command line. And I think there's plenty of places in the compiler where you can see that all sorts of workarounds have been introduced to support this. For example, looking at the file name, if it's package.scala, so I talk about sources now, then you do something. But again, people don't name their package objects consistently. So package.scala is a convention that's not enforced. So again, this leads to really brittle or fragile, I guess, depends on how you look at it, compilation. So I think it's not really working very well. But yeah.
I think that in Opaque we actually have solved most of those problems. So I don't really think we do special, we have a lot of special code for package objects in there. The first problem you mentioned, I mean, if we really take it seriously, the package objects are objects, and package objects should not be able to extend the class defined in the same package, period. So,
absolutely, but yeah.
But at the same time, I mean, the only times I've seen a package object extend something, they did extend something within the same package.
Yeah, that should be.
So if we refuse that, well, probably we might as well refuse all extensions and be done with it.
I think as
and then package objects are semantically more or less the same as top-level definitions, and we can consider
but changing top-level definitions, you're opening a whole kind of worms as well. So what if you have several? What if you have several source files containing top-level definitions? What if they define the same thing? What if they define overloaded things? So
well, what if you have two source files that define the same object foo? Like,
well, that's an error.
Exactly, that's an error. Well, defining two top-level definitions with the same name will be an error.
And
it kind of works.
What about overloading resolution? So if you have overloaded methods in different top-level objects, if they're top-level, then you have to resolve overloading. But that so the dirty compiler wouldn't like that at all, because it means that suddenly that you have a bunch of overloaded methods that have different prefixes that come from different objects.
No. I mean, they would be in the same prefix, of course, in the simple table. It would come from different class files, but or different source files, but they would end up being part of the same member scope.
They should definitely have the same prefix, I would have thought. I'd be surprised if they didn't.
It's the same with classes. Like all the classes defined in the same package.
We don't do overloading resolution on classes. So.
Not overloading resolution, but it's not specific. Like,
so I'm sympathetic to Julian's point, but I think it's in some ways, if we remove package objects to make incremental compilation better, but then we introduce these top-level objects, we're back right in the same boat, right? Because tons of source files might define different top-level objects, and to know what's in scope, you'd have to look at all of them. So, I mean,
the incremental compilation problem is related to extending from classes again, right? It's not really package objects per se.
But how do you even find out which top-level files contain, or which class files contain top-level objects?
Well, we're going to look at all of them anyway, aren't we?
They have a Scala signature that says that.
Yeah, but to find out where foo is defined, right now I need to find the class files that mention foo.
Yeah, okay. So then it depends on whether we choose the strategy of putting them in something that's derived from the source file name, or whether you create one class file per name.
Yeah.
If you create one class file per name, then it's easy because the class file will have the name.
Overloading again?
So, and if we choose that strategy, then overloading across different things can only work if we add the signature as part of the name of the class, which is fishy.
Mm-hmm.
The other strategy where we put everything in depending on the source file name is, well, we give a specific prefix that says this is top level $, the name of the source file, and then you just look for all the class files whose name starts with this prefix, and that's it. It's not hard.
Might it be possible, not to get rid of package objects, but just put more restrictions on them, like figure out what works, figure out what doesn't work, figure out what people need, what they don't, and then just bake those restrictions in, so that would avoid having to throw out a language concept and then introduce another language concept.
But I thought the proposal was only to forbid extension, so package objects should not extend something. But they would
open at this point.
Yeah, I mean, we still have some time to discuss this, and maybe in the interest of time, we should move on to other things.
Mm-hmm.
But I think the spectrum is basically like, I think we all, well, some of us agree. Extension and package objects is tricky, and maybe we should just get rid of it entirely because there are very few valid use cases, and it's usually tricked into doing something that is hard to really understand.
Maybe one question I still have is what does a package object give you that a top level object doesn't give you? So why do we need them?
Because
they're values, they're first class values.
So, the big place where we've used them at work really successfully is you can introduce stuff into the namespace without needing imports, right? So if you want something to be in scope for everybody in a particular package, you can use package objects to control that without the user having to do imports. And it's sort of a similar way that we use Prelude in Scala. With an object, you can't get that behavior, so you'd have to have everyone import it wherever they need it. That's really the main one, especially for like implicit evidence or implicit values. It's really handy to have that package object around, basically.
You also cannot have a sub-package of a package that would be an object. Like if you have an object foo, you cannot have a sub-package foo.bar. Whereas with the package object foo, that works. So that's one thing that the package object gives you that the object doesn't give you.
But why would you want to create a package object for that? You just, have a package definition that says, hey, I have a package that I want to create a sub-package of. What's the? I don't get what the use case is.
Well, you have a package foo, and you have a sub-package foo.bar, and you have stuff in foo.bar, but you also want top-level definitions in foo.
Yeah.
Then you need a package object in foo. You cannot have this structure with an object foo.
Oh, well, but why don't you just define the package foo and put stuff in there?
Yeah, if you have top-level definitions, then we can do that.
Oh,
Absolutely.
you mean if you want like a type alias or something in there? Or
I think top-level definitions are probably easier to work with than package objects. Yes.
Yes.
Yeah. I think
I have a comment here.
Two people. I think package objects kind of pretend that they're objects, but then when you use them all the way like they are actually objects, you quickly run into problems. I think that's like the synthesis of the problem.
So basically, for the normal users that we envision so far, the compiler, when it opens a package, it has to scan the package object to essentially populate the scope with the members. Now it would have to scan all top-level $class files, merge all the definitions, and that would be it. But for the user, it's much easier to just essentially not have a restriction that top-level things must be objects or classes. Can just write them anywhere. So I'm quite in favor, actually.
Okay.
So let's move on.
Let me comment on that.
The notes and go to the next one. I'll start
this has been a very exciting discussion. So there are still
So
one down, two to go.
So remind me what the second one is.
Yeah, there is another one that Adrian has mentioned in several places, which is basically constraining macros with black box and then replacing some of the legit use cases of white box macros with special features within the language. That would mean having support for type derivation, right? Type of derivation, first class support in the language, and more of these cases. So what's the
yeah, I think we have a whole meeting on this topic. No, I mean like he's cherry picking I have like a list of 20 tickets on the 214 milestone. And he picked the 3 that give the easiest discussion.
Yeah.
So
hey guys. Hello.
Hi.
So I have some comment about package objects. And then we can move on to macros.
So just before we go on with that, I'm just going to voice one of the comments that was sent on the. So someone said, "I'd be happy to have only basically type and val var at the top level and forget about defs, which would eliminate the parent overloading."
Yeah, that was a Stephen compound.
But I think with the scheme that you outlined, we won't have a problem.
I don't think there is an actual problem. We can make that work.
If you merge all top-level files, just treat them as one package object.
Exactly.
Top-level definitions certainly make opaque types. So
that's true.
This is part
actually the one thing we should probably not do is statements and vars and such top-level objects because they are order dependent. So if you have several, you don't have an order for them.
Yeah, that's true.
Yeah. So defs are okay, but vars are not.
That's a good point.
Yeah.
So Jean, can you please comment?
Yeah, sure. So just to summarize what you guys have been discussing so far, it's great that I've been making notes. I have an advantage. But yeah, Adrian also did. So yeah. Anyway, so there were lots of arguments against package objects in the sense that they complicate the implementation of the compiler, the IDE. Also, they mess with incremental compilation. I think before moving forward with changing them, it would be great to essentially document this, because the current behavior is pretty much unspecified. Whatever is in the implementations, it's actually the spec. I think it's quite hard to objectively estimate the detrimental effects. So we all hacked on compilers, and on Scala and other stuff like Dotty. So we intuitively understand that, hey, package objects are a mess. They're annoying. That's another special case that have to be taken into account. But I think we need to be objective here, because we have the perspective of compiler hackers, but there's another perspective of basically industrial users of the language. So the question here would be, why I think it would be beneficial to objectively estimate the problems, is that, removing package objects, that will lead to breakages. So let's say, there are companies, and not just ours, that have millions of lines of code of Scala. So how many code will be broken? How much code will require rewrites? Manual rewrites. No. So just
One pretty easy migration path is to say, well, first, dropping extending classes and traits, that is a breakage that cannot be, that needs to be migrated away manually.
Yeah.
But we can first deprecate that and have a deprecation cycle for this, and it's possible.
No. So one comment about deprecation cycle. So if we deprecate that, we still need migration. It's not going to happen, magically. So let's say, as I said, well, here at Twitter we have millions of lines of code. So it's like, can you imagine how much time it would take to change this stuff manually?
No, sure. So here I'm talking about the extends thing, right?
Yeah.
As far as objects per se are concerned, I think we can automatically.
Just drop the object.
Basically, we can very easily automatically translate them into.
Just drop the object. Then it will convert one to the other.
Yeah.
What do you mean by drop the object? I couldn't hear that.
Where you wrote package object foo, now in the future you write package foo, and it's going to be legal. That's all.
And the compiler could just drop it for you. Like,
yeah,
it will whine. It will say the object there shouldn't be there, but it will treat the package object as a package with packages.
What about extensions though? Because that's not going to be supported, right?
Yeah, no. Extensions is a problem.
So I think the question back would be, let's quantify this. We are at a point where we can do those queries on big code bases, and just get a number, like how many actual extend clauses are there in package objects in your code base, in the community build, and so on. So I think those are important concerns, but we have a whole meeting ahead of us, and this is number 1 on the agenda. Well, number 3. But
well, I think this is an important methodological concern. Like, how do we evaluate this proposal?
That's the intent here in this meeting, that this is a topic that we'd like to
investigate.
Yeah, investigate, start the discussion. I don't know if a live venue is yes, the concern is clear, it's heard, and let's look into it.
Okay, if there's an agreement on that, then it's great. But I just like to know that the burden of this should be on the proposer, not on the people downstream.
But Eugene, it would also be great if we would get the data from Twitter's code base, like how many packages do actually do an extend.
Oh yeah, sure. I can discuss that with legal, and we also have the community build, right? So that's another data point.
But should be rather easy to get this information and then act on it. Okay, so I thought that this was the most trivial thing in 2017. But I've obviously learned a lesson. I've learned a lesson here, so I'm just gonna skip the 2 remaining items.
Skip one for the session.
I think so. And I don't think that would even.
Okay.
Be sufficient for a meeting. So
let me just mention that all these are listed on the Scala dev, Scala/Scala-dev 214 milestone. There's just a list of all the tickets. So go over there and comment with your concerns. I think this is the right place to collect those things and to make sure that we don't forget them and act on them. I guess we can we'll post a link in the proceedings or in the transcript.
Yes, we will. Okay, so let's move on now to zip35 Opaque type. Well, no, yeah, zip35 Opaque types. Just in case Eric has to go soon. So Seb is the reviewer of this zip. It's Eric Osheim is the other co-author of this zip together with me, and he's joined the meeting just to discuss the details about it. He just pushed recent updates on the proposal this morning, and there is some fresh news to discuss. But I will let Sebastián deal with that and introduce the changes and also voice his concerns.
If I remember correctly, we skipped it in the last meeting. So
yes,
actually, we have a lot of changes to discuss compared to the first one. Which is more than just the few more changes that
I propose we don't dive into the implementation details. No. Let's just discuss the high-level details of the proposal as it is right now.
So, I mean, the proposal has been substantially expanded, especially in terms of examples for motivations, and some details about the semantics and how it should type check and stuff like this. My main concern is that the proposal oversells its promises. In particular, I think it's not intentional. I think it's just that the proposers and pretty much everyone doesn't really realize that things won't work as well as one would hope. So in a lot of cases, the proposal says, hey, this will not box in this case. It's going to be great. It's going to be performant. But actually, it will actually box in a few cases. And
so I actually added. You probably didn't see. I actually added a note about that. I guess the needs to be clarified. I think, like, the language that the spec is using is trying to say box, in a place where the underlying type wouldn't. So, for example, I tried to clarify that for primitives do get boxed in some cases, but specialization will allow them to not be boxed in others, and opaque types preserve that. So, for example, list of double does get boxed to Java lang double, but like tuple2 of double doesn't box, for example. And that's a case where an opaque type you would see a benefit for tuples or for specialized function 1. You wouldn't see it for list as much, but like the point is that the author is going to get the semantics of the underlying type, whatever those are. So if the author is content to use double, they're presumably content to have list double box the doubles. Maybe the value class is acceptable in that case, but then there's other cases where it's not. So I apologize that it wasn't as clear in an earlier version.
Yeah, I have. I know about this. I was going to mention that as well. So that is one thing that often happens in the current text, and another one is that it mentioned that it won't box in cases where indeed it won't box, but at the same time the anyval version wouldn't box either. So we're not getting much compared to anyvals. So if I really look into all the possibilities in all the cases, there are three main cases where opaque type aliases would box less than anyvals. One is, as you said, if you have primitive types, underlying primitive types, and we use specialized stuff in conjunction with those, then the opaque type aliases would not be boxed, whereas the anyvals would. Another case is if you have an anyval or an opaque type alias whose underlying type is a reference type, and you use that inside the generic context. Because with an anyval, you would box the reference type, say string, inside the anyval class and put that in the list, whereas with the opaque type alias, you would put the string in the list. But if it's a primitive type, then, as you mentioned, you trade boxing it inside the anyval class versus to box it inside the Java lang double, so we don't gain anything. And the third case, of course, I forgot it again, but it's not really a big deal.
Maybe you meant arrays, which are kind of like, they're not exactly specialization, but it's similar.
Yeah, exactly, arrays. Yeah, that's right. So arrays of opaque type aliases who are wouldn't be boxed. But if I go over all the examples that are currently in the motivation, most of them actually fall in the cases where we don't have much improvement. Let's say, for example, the tagged example, we would assume that this is a very nice one, but in fact, the double tagged with meter, indeed, the alias is to double and doesn't box itself. But the call to the tag method, if I tag 5.tagMeter, I'm calling tag, which is a generic function, a completely generic one. So my primitive double is boxed as a Java lang double to call tag, and then is unboxed afterwards.
I have a question for you. Would you have preferred, because I actually thought about doing this, if you could annotate it with specialized, then it wouldn't happen. I feel like that makes the example maybe less readable, but then it does avoid boxing. So that was something that I actually thought about when writing the example. And you're right that if you use the unspecialized generic, that it doesn't work. but actually specialization would work there, and specialization never works with value classes. So that, I think, there's a trade-off there.
It would be worthwhile for the text of the proposal and the examples not to lie. So I would advise for the add specialized version, even if it's less readable, at least it would be correct. Because right now, if a not very attentive or not very knowledgeable reader reads this, it gives too much excitement. It promises too much.
Can I ask a question, which I think is sort of aimed directly at that comment? I confess that I had not actually thought that avoidance of boxing was the primary motivation of the SIP. I mean, Eric, could you correct me if I'm wrong? I was under the impression that what was going on here was actually adding an interesting semantic feature to the language. So in other words, something like tagging is actually the key aspect here. And whether, I mean, and the question of whether or not this actually gives us a win in terms of boxing, that's a nice to have if we can have it, but it's not the primary goal. Is that was I wrong in understanding?
So I think you and Jen are both sort of right. I mean, like, I think the proposal initially, when Jorge approached me about it, the first version was like, let's make value classes but better, like make value classes that are less leaky in terms of being an abstraction. So that was where it started. But then once we started exploring the opaque type concept, I think you're right, Miles, that actually opaque types seem to offer a lot of advantages besides avoiding boxing that actually we're very enamored of. Like, I think it's a better model for sort of information hiding or tagging or some of these other applications. And actually it's nice because it's a language construct that, because it's completely erased, it doesn't impose anything on the runtime. So one interesting thing is that, like, it's much more compatible with, say, future Java generic specialization or future Java, Valhalla value classes than other Scala language features, because it doesn't actually, it's completely evaporated by the time, it's interpreted. So actually, Miles, that as we've updated the spec, I think we've tried to move away from just focusing on performance to saying, actually, there's some interesting semantic stuff. And so I think the hope was, and maybe I guess it sounds like it wasn't very successful, but the hope was that a lot of these examples would show off interesting semantic stuff that could be achieved with opaque types. Like, for example, the immutable array instance is a case where there's some performance concern, but actually it's nice that we can restrict the operations used on these arrays. So yeah, I mean, I think you're both right, really.
I think information hiding is a perfect use case for opaque types, and I think it enables lots of different library designs that would be very neat and would be also performance friendly in some cases.
So if nothing else, I mean, there's a couple of things which are in Shapeless, in Scala Z. I don't think there's anything in Cats, but the type tagging stuff is really widely used. It would be really nice to be able, and it's an accident that it works in current Scala. It would be very, very nice to have an intrinsic, a language intrinsic that was able to replace that. I mean, right. that from my point of view, that on its own is enough to make this SIP look very, very interesting, irrespective of anything it might have to say about boxing or not.
Yeah, I mean, another motivation of the tag example was I had a conversation with Adrian maybe a couple years ago, how Adrian didn't like the existing tagging strategy because it is kind of a hack and it's an accident that it works. And he suggested using value classes for tagging. And I sort of pointed out that current value classes are very inappropriate for tagging and introduce like a ton of overhead relative to the benefit you get. And so that one reason it includes this is a nice way to show that this would replace that sort of like hacky compiler tagging strategy with something that actually isn't going to penalize performance above what the user might already be willing to accept, say with like list double.
Yeah, and I mean, I really like opaque types, and I think actually that's generally the sentiment. I think Sebastian was just pointing out some things that could be misunderstood by people who are reading this quickly. And I mean, maybe one way to summarize the changes in boxing is it just makes it easier to understand what things are boxed, and it basically reduces it to the boxing like behavior, let's say, of the underlying type, rather than having to understand a little bit more the way that we have to compile value classes, yep. which is a more difficult story to understand.
I think there's a specific sentence exactly about that. Okay. It just behaves the same as the underlying type.
Right.
But in the case of type tag, I want to emphasize that opaque types would indeed remove one layer of indirection for any ref classes. So it wouldn't do it for if you are tagging like primitive types, but it would do it for any ref classes as well.
Yeah, we mentioned that.
Just want to emphasize it a little bit more.
So maybe let's move on. I think it's a valid point that the language has to be precise. but I think we're also more interested in how does everybody feel about the proposal, conceptually, and where it stands in terms of.
Yeah. I mean, to me, it has always been about the semantics. It's just that when I read the proposal, it looks to me like the proposal is not so much about the semantics as about the performance of the boxing stuff. I think the proposal talks way too much about the boxing and not enough about the semantics.
Okay, so that's one action point.
Yeah, that's one action point.
And to give at least one very pragmatic and immediate use case that is really semantically defined and not at all about the performance aspect is that look at the CL traits extends JSNE that we have in Scala.js, where people actually encode. I mean, I came up with it initially, I think, but it's widely used as a super hacky way of encoding what should be opaque type aliases. But in terms of the CL traits extends JSNE that don't have any subclasses, and we just cast to it because JSNE you can always cast with JSNE, it always works. So that is something that is already used very widely in the Scala.js community, which should be an opaque type alias, but we don't have opaque type alias, so we came up with a very hacky way of doing it. And it's all about the semantics.
Cool. I just want to raise one red flag, and that's the recursion. So we already had a discussion on .the issue tracker. That's is opening a huge can of worms. So I think it's not an option to introduce a new kind of recursion into the language, which this thing would do. It's a fundamentally different kind of recursion that goes over type variables instead of the self that we sort of have tanked now in Dotty and Dot. But I will not be comfortable or put up with adding a new kind of recursion to the language. That's way too much.
So that would be the fixed point type example.
That would be the fixed point type. That will never fly.
In the spec, yeah.
So the best one could maybe achieve, but I haven't seen it done. I haven't seen it done exactly how to do it. So if one could somehow define two different types into different conversions, but then I think we did it. The proposal shouldn't do this. This is sort of a huge thing. This is sort of 10 times bigger than the rest of the opaque proposal to add something like that.
Yeah.
So maybe let's give the authors a chance to respond to that. So how do you feel about that part of the proposal?
Well, so it's interesting. I mean, I don't think the proposal, like, that's not a hill I'm going to die on as far as, like, that we can't remove it. It's something, the reason I brought it up is it's something that people are already doing via some kind of, like, again, kind of these like compiler tricks in Scala 2, where you can actually encode a fixed point and have it work this way without actually introducing like a real wrapper. So I thought, since this is apparently already possible, that maybe it'd be interesting to see how it would work here. But and I thought it was interesting, like, if it was possible, it's good to document that it's possible. I think if it's not, if it's gonna be forbidden, we should document that it's forbidden. I think I can certainly live with that. But
Me too.
Quick question for Martin. I'm not going to disagree with you, but you say this is a fundamentally different kind of recursion. Can you kind of sketch out how it is a different kind of recursion? Because to me it looks, I mean, the fact that it's spelled type rather than class doesn't obviously smell to me of it being a completely different kind of recursion.
So let me think. So what I was getting at is that in Dot, the recursion is always over the self of the current object that we define, of the current structure that we define. So that's the thing that we can recurse over. Whereas this looks like a recursive type, which recurses over essentially a type parameter. And I'm not exactly sure one could encode it in the self recursion. It's conceivable, I'm not sure. But I do know that essentially the whole type checker will fall over if you do this, because that's just the recipe to essentially create all sorts of loops and cycles. So that's
I'm also falling over while reading it.
I mean, unless I'm missing something, that fixed type. I mean, you could translate that very, very directly to a class. Is that right, Eric?
Yeah.
Yeah, and I'm sure that would still be valid in Dot.
And then if you have,
the only real, I mean, syntactically, there is a trivial translation from that type to a class type. Is that really fundamentally changing the nature of the way that it's type checked?
The alias to its body, it introduces a new name to represent the recursion.
So what you can do is you can say fix of f. And f of fix of f, you have two. There are two different types, but you have two conversions from one to the other. If you have two implicit conversions, then it's up to you. We know that this is really dicey to have implicit conversion going back and forth, so I would recommend you make them explicit. But the point is there are two different types and you have conversions. That's fine. But what the opaque types proposal would essentially imply is that these are really the same type, and that's what where compilers would panic when they see something like that.
Right. Yeah, I agree. I agree with Martin that the the reason you can't use a type alias for this is because you immediately try and resolve it, and you're gonna infinitely recurse, and so then the question would be you have to introduce some kind of staging, and maybe that's just not what we want to do. So yeah.
So yeah,
I agree with that, but I think that implementation wise, at least in Scala C, this would be feasible without introducing more cyclic errors than we have right now. Because the typer only,
which is so good.
Well, at least it will inbox this. But the typer only sees the static typer only sees the class, and then after typer do
inside the companion object to see it, and that's enough.
The problem is inside the companion you have this immediate expansion of the type alias. Where with a class you're safe because you can just use the name of the class to represent what it stands for and all the possible subclasses that it kind of recursively expands to. But like you don't know where to stop with these. I think that's what Eric was saying as well. So since this is a relative niche, and like overall we're pretty happy with the thing, let's just put this on hold. Indefinitely. We can definitely. I mean, this example. I mean this recursion, not the obviously not the.
And the controversial one is
that. Again, in the interest of time, because we're already like 47 minutes.
Cool. So
is that like let's just give those that are virtually present a chance to chime in if there's anything that you felt like you wanted to add before we move on. Okay. Thanks.
I just want to clarify that opaque types has been implemented in Dotty. There is an open PR about it, and we've been discussing about it as well there. That's where this issue was raised at first, and it's being implemented right now in the Scala C because we had to change this implementation strategy, and I will also push an update on the SIP explaining what the new strategy is. So let's just move to this third item of the agenda. That's a by name implicit arguments proposal that Max has been working on.
So to clarify the status of the SIP itself, now we're basically waiting for a Scala C implementation.
We are waiting for a Scala C implementation, and we will act on the actionable feedback that we have now. So for the next iteration.
I'm sorry to go into like the meta stuff here, but is a SIP dependent on having an implementation? Because I know that the Scala C one is going to be tricky. But
I think that's part of the requirements that there is a Scala C implementation before we can approve a SIP.
Okay, well. Go.
I think
otherwise, what's the point? Like,
well,
we're going to approve some language feature and we don't have an evidence that it's implementable. Like,
well, it is. We have evidence in Dotty, right? I mean,
in Dotty, yeah.
And but I think in general, having a sense that it's quite likely to be implementable is, for me personally, actually enough to say this is a feature that we would like. Not knowing exactly how you implement it yet in I'm going to call my code base the legacy code base. I mean, because I just want to acknowledge this is a hard thing to implement in Scala C, because we don't have any context dependency in subtyping.
Actually had an idea that may be working around that.
Okay, well, yeah, let's
we
talk
can
about
discuss.
I don't want anybody to know about our
Yeah,
hacks.
we can discuss that later.
Yeah.
So anyway, so I will try to get an implementation for the next meeting.
Right.
We'll see.
Well, yeah, let's try that one.
Yeah. Cool. So let's just move to the third item. So Miles, would you mind giving us an introduction into the SIP? I've already kind of proposed to Martin to be the reviewer of this proposal for the next iteration. And now we basically need to decide whether we're going to number this proposal or not. So it would be good to know a little bit what the motivation behind these changes and what changes you have in mind.
Well, I mean, there are many motivations. One of them is that I do not want to have to look after the lazy macro in Shapeless for any longer than is absolutely necessary, because it's absolutely hideous. So basically, biname implicits is essentially a way of adding to the language the semantics that lazy is intended to provide in Shapeless. And basically, the intended semantics are an ability to tie a knot implicitly, tie a recursive knot implicitly. And this is something which comes up in the context of trying to do type class derivation for recursive data types of any sort. So for example, if you're trying to produce a type class instance for a recursive ADT-like list, because the structure of the data type is recursive, a type class instance for corresponding to that data type is also going to have to be in some sense or another recursive. So if you're going to produce that instance as a result of implicit resolution, there has to be some mechanism available for implicit resolution to produce a recursive value. So kind of lazy does this by kind of brute force, by in effect turning off divergence checking and rather brutally constructing some kind of a patched together value containing a bunch of lazy definitions which can be stitched together into the recursive value. The by name implicit SIP and the implementation in the Scala PR do this in a much more principled way. Basically, it turned out, and it was a really nice coincidence, actually, I guess. I realized a while back that there's basically an empty space in Scala syntax to hang this stuff on, because there had been no prior meaning assigned to a by name implicit value. So this convenient little bit of perfectly formed syntax available to actually hang some semantics on. And I've kind of lost my thread, actually. Where was I? So we've got syntax to hang the semantics on. There's plenty of good motivating applications for it, I think. In terms of the implementation, it's a great deal cleaner than the implementation in the macro and Shapeless. I mean, in actual fact, in terms of the number of lines of code, it's orders of magnitude smaller than the horrific hacky macro thing, which has to cast its way to internals of the compiler to be able to do its job and this kind of stuff. So I think in as much as it does the same job in a cleaner and more principled way than existing library-based, macro-based infrastructure. From the principal point of view, one of the things it can do, which the Shapeless macro, I'm pretty sure probably really just couldn't ever do, is actually do a sane check for divergence. I suspect that's one of the things we'll probably want to talk about, maybe not today, but eventually the most, is the new criteria I put together for divergence. I think that we kind of need both the raw mechanics of capturing a by name implicit argument and also the associated changes in divergence to actually really do the job. But ultimately, the motivation is to get rid of a bunch of macros. And I think from the point of view of being able to shift chunks of the Scala ecosystem from Scala in the direction of either Dotty or other Scala compiler implementations. Actually having that as a simple language intrinsic is a really good thing to have.
I have a question with regards to the usage of implicit, well, binary implicits and the lazy macro in this case, which is widely used in lots of open source libraries, the Scala open source libraries. Have you noticed a performance difference with regards to the implicit search? Because I know that in some cases the lazy macro was causing lots of stack overflows if you didn't have a huge stack space, or if you were trying to derive a concrete type class for a huge GAD.
Well, I think it's entirely possible that what people were seeing in lots of those cases are straightforward divergence, actually, because the lazy macro turns off divergence checking effectively, which means that if you do actually write an ADT which is or an expansion which is actually diverging, you're going to be in trouble. And it's typically what's going to happen is someone's going to have a very large ADT. It's actually not that easy to spot something which is actually going to cause divergence. It can be quite hard to see that there is actually something there which is going to cause divergence. So I suspect a bunch of these situations, someone put together a very large ADT, they've thrown lazy at it, the compiler's blown up with the stack overflow, and the conclusion is not, oh, actually there was a problem with the underlying data structure, which meant that what you were trying to do was going to diverge. Actually, sorry, it just looks like, okay, there's a huge runtime overhead, and it's blown up because of that. I don't. So there is. I think there are some. I mean, there are definitely some opportunities for compile time performance improvements using the intrinsic. I mean, there are definitely some overheads involved in lazy. One of them is that obviously we're creating a bunch of funcs. Each of the lazy wrappers creates a func. It turns out that in practice you need a lot less by name arguments than you need lazy in practice, and then that's largely to do with the way that the divergence checker obviously it's aware of the fact that there might be by name stuff somewhere, so you don't need to have it everywhere in order to be able to kind of get the divergence suppression stuff. So in typical cases, you will be able to eliminate a whole bunch of funcs, and that seems like a small but not absolutely overwhelming improvement, but it's it's nice to have. I think basically the by name switching to by name will improve things in all cases, but it certainly won't make anything worse than it is currently. That's for sure.
Thanks. So does anyone here have any comments on this proposal, or?
Yeah, of course I have. Always have comments. So one thing is, I have never done any kind of recursive derivation myself, and yet I am completely sold on the motivation of this SIP, which means that it has done a great job at motivating itself. So that's a very positive comment, because usually SIPs, I am really not sold on their motivations, even when I like them. So props for that. I have one concern, which in my opinion is pretty major but fixable, about the semantics, which can be seen in the desugaring. I mean the result of the implicit expansion, even if in the proposal summary, which is that it desugars things into lazy vals to tie the knot, and I think that is wrong. It should desugar into defs. I understand the performance point about using lazy vals, but if we use lazy vals, then it is not consistent with non-implicit binding parameters, and that is bad. In the sense that if you write the exact same program that one has implicit foo by name something and foo by name something, they won't do the same thing, even if you call implicitly or explicitly provide the parameters. So I think the feature that is
just a quickie. I mean, do you so actually, I think the desugaring is probably going to work if it desugars to just plain vals. In fact, I mean, this is something I need to experiment with.
No, with vals, this desugaring here doesn't work.
With a def, you would again get.
Oh yeah, it's by name. Yeah, maybe work with
no,
vals.
so it is by name. So in fact, I think the lazy prefixes are redundant there. That's something I think I need to confirm that.
Val also executes it only once. And a by name should be executed every time you refer to it.
No, you're both wrong.
It's 6 o'clock. Let's try to keep
the lazy val is essential. I'm the only one who has actually implemented this, and the lazy val is essential.
No, Martin, you aren't. I have implemented this as well.
No. A def would give you divergence again.
No.
Yeah.
No, you just in the code that you generate, you just write def here instead of lazy val.
Here.
You haven't changed anything else.
Well, people can see it on the.
Yeah, sure, but it's really hard to like. So I told it was in the very first section, like in the desugaring that we see. Turn the lazy val into a def.
Lazy val rec
the code of the compiler doesn't change except.
Actually, I'm definitely wrong. So I think it should be lazy val.
Okay, guys. So let's move this technical detail to another.
And there's a misconception that this is lazy and not by name, but that's actually not true. So the parameter of the method is by name. It's evaluated each time. Then the question is, what do I manufacture as an implicit argument for this? And the lazy val is in that argument. That's again why a val is wrong, because when I produce the argument, I should not evaluate the argument. It's a by name argument.
The lazy val is equally wrong.
Okay, so maybe a val would be.
If there is a side effect in this method foo here, in the implicit def foo,
yeah,
then it won't produce.
Well, I think if any, I mean, shall we not open the can of worms of implicit definitions which have side effects? I think
let's move this.
If people do that, they deserve whatever they get.
Yeah,
well, yeah. I mean, I think because it's so subtle, I think it's better to discuss these things on the floor,
like
that, because otherwise you have to point the paper on camera, which is tricky to follow. So let's keep it at the conceptual level for now and take the technical details.
So let's proceed with the voting. So the problem here is that Julian has left, so we don't reach the quorum. So we will get his vote on numbering this proposal and the vote of the people that have not been able to make it for this meeting after the fact. But right now, I just want to get a voting and know if there is someone here who disagrees with the motivation of this proposal, just to number it. So we can probably get the voting now, and we will see what the result is afterwards. And we can otherwise just have like an email voting. Okay.
That's good.
So is there someone here? Let's just make it easy. Is there someone here that is against?
Please,
please,
no,
yes.
abstention.
Every
Okay.
time.
Don't.
Okay, let's make it easy.
Okay.
Seb?
Yes.
Yes. Let's number it.
Yes.
Sure. Yes. I mean.
I think so, but.
Nice says yes, of course.
Seth? Yes. It's a thumb. Okay. I'm like, what's this?
It's so he can. It's so he can claim he was upside down later if there.
And Eugene?
Yes, I'm in favor of that.
Okay, so we'll give the final result after in the minutes, and we will probably tell in the Scala contributors YouTube channel as well. So thank you for joining us. Very nice and productive discussions.
Very own Scala reality show.
More next month, and thanks for being there.
Thanks for watching and
Thanks
commenting.
for watching. Yeah.
Thanks for bearing with.
Yeah.
Stay tuned.
Live, so thank you so much.
In the next video.
Thanks everyone for your comments.
See you in a month.
I can't believe what happens next.
Bye.
Okay.